Okay, so let's look at how to solve multi-step linear equations. Here's an example where 6 is multiplied by x and then that is added to 1. So we have to get every term with the variable 6x by itself first. So I need to get rid of the plus 1 by subtracting 1 on both sides. We end up with 6x equals 12, and now we can get the x by itself by dividing both sides by 6 to undo the multiplication by 6 right here. And 6 and 6 reduce to 1 and 1. And 1 times x is x, and 12 divided by 6 is 2. In this example, we have x terms on each side, so we need to get all the yellow terms together on maybe the left side, and then we need to get all the numeric terms together on, let's say, the right side. So I need to get rid of my 4x on the left by subtracting it, so I have to do it on the left side as well. Sorry, I need to get rid of the 4x on the right by subtracting it. And then I need to get rid of my minus 4 on the left by adding it, so that all the purples will be on the right and all the yellows on the left.
The author that was doing this makes a mistake here, so I'm just going to finish this problem off. So we add the negative 3x and the negative 4x, we get negative 7x. Negative 4 and positive 4 is 0, and then 4x minus 4x is 0x, and 1 plus 4 is 5. Alright, then what we need to do is just divide both sides by negative 7. So I divide by negative 7, and we get that x is equal to negative 5/7.
Here's an example with parentheses, and what I like to say is that when we have parentheses, you can't see what's inside them. They sort of hide things from view, like they're walls that we can't see through. So we have to somehow break down those parentheses, and we can do that by using the distributive property. So I will distribute my 2 on through both of these terms, so I'll multiply each of these by 2. And this negative here is like negative 1, so I'll distribute my negative 1 and multiply it by both of those terms. 2 times 3x is 6x, 2 times positive 1 is positive 2, and then I carry down my plus 4 since it's not inside the parentheses. Negative 1 times x is negative x, and negative 1 times positive 1 is negative 1. Okay, a couple things we could do. I'm going to try to get every term with x on the left side, and then all my numeric terms on the right side. So I need to add x to both sides to get rid of the x on the right, and then subtract 2 and subtract 4 from both sides to get the purple guys to the right. 6x plus 1x is 7x. All the numbers drop out. Negative x plus x drops out. And negative 1 minus 2 is negative 3. Minus 4 is negative 7. And now we can divide both sides by 7 to get x by itself. So x equals negative 1. Here's another example with parentheses where we must distribute to unhide the things inside. 2 times x is 2x, and 2 times 1 is 2. Let's get all the x's together on the left side, so I'll subtract 2x from both sides, and get all the numbers together on the right side by subtracting 2 from both sides. 2x minus 2x is 0, 2 minus 2 is 0, so the left side is 0, and for the same reason the right side is 0. So here's an example where the variable disappears completely. Whenever that happens, if you get a true statement, 0 does equal 0, that means it doesn't matter what x is. No matter what x is, this equation would be true. So the solution to the original equation is x could be any real number. So all real numbers are solutions to this equation. Any number you could think of, you could plug in for x to the original equation, and it would be a true statement. Here's a similar problem. Distribute our 2 on the left, and we end up with 2x plus 2 equals, sorry, I wrote the original problem wrong, equals 2x plus 3. Subtract 2x from both sides, and subtract 2 from both sides, and we end up with 0 on the left, and on the right, 3 minus 2 is 1. The variable disappears again, but there's no x, so this is not a true statement. 0 never equals 1. That means no matter what you plug in here for x, this statement will not be true. So there is no solution to this equation. No matter what you choose for x, this statement will never be true.